The last question in worksheet 6b, relative max, the relative min or saddle point at x cubed, xy, y cubed. Okay, I told you, you need to find the derivative with respect to x. That's 3x squared 3y, and make it equal 0. Derivative with respect to y, 3x 3y squared, and make it equal 0. From the first equation, if I bring 3x over, so 3y equals negative 3x squared, divide by 3, y equals negative x squared. Now put this into this equation, so 3x plus 3, instead of y, I'll put negative x squared squared. So I have 3x, negative x squared squared would be x to the 4 times 3, 3x to the 4. Take 3x as a common factor, you have 1 plus x cubed. Meaning that x either 0 or minus 1. When x is 0, y is 0. When it's minus 1 squared is 1 times negative minus 1. So you have 2 points. The 0, 0 and the minus 1, minus 1. We need to know if these points are max, min, or saddle. So we need the derivative with respect to x again, at 6x. Derivative with respect to y again, 6y. And whatever we did with x, we do in terms of y. And that would be 3. We plug, so I'm gonna test the first point, 0, 0. At 0, 0, this gives me a 0. This one at 0, 0 gives me a 0. And this one at 0, 0 gives me 3. I do the d, where it's fxx, fyy, fxy squared. That would be 0 times 0, and 3, that will be negative 9, that's less than 0. This point is a saddle point. I told you when d is negative, it's a saddle point and you don't need to do anything special. We'll test the other one. Let's test negative 1, negative 1. fxx at negative 1, negative 1 will be negative 6x, negative 6. And fxy is 3. So we do the d, which is fxx, fyy, fxy squared. This times this is 36. This squared is 9, that's 27, that's more than 0. Positive, and these two are negative. This one is a relative max. Good? In the midterm, one question that I want to correct in the midterm, first of all, that remember that last part in the midterm review that I told you is optional. Now it's no longer optional, you need to do it. It basically covers the same concepts. The derivative, tangent plane for a surface, linear approximation, and relative max min. I solved them, but I'm gonna change my answer to question 14. So review the video. Only question 14. I want to change the answer. The surface itself is z squared x squared over 6, y squared over 9, and 1. I told you, equation of tangent plane is different than tangent to level surface. This is just a surface. So you need the derivative of x minus the point, derivative with respect to y minus the point, and z minus the point equals 0. So you find the derivative with respect to x first. Now, the derivative with respect to x for this would be 2x over 16, which is x over 8. With respect to y would be 2y over 9. You plug the point, and the point that you're plugging is 4, 3, negative root 3. You plug 4 here would be 4 over 8 half. You plug 3 would be 6 over 9 2/3. And this, you put everything in this. So you need the derivative with respect to x, which is half. X minus the point. The derivative of y minus the point. And then z minus whatever the z point is. So minus would be plus root 3. And you just leave it like it is. This is what you need to know for this question. Okay? Good luck.